Great. Right. Banya. Hello.
Hello, sir. Sir.
Can you hear me?
Yes, sir. Yes, please. I can hear you.
Okay, so if it is not working well with your Zoom, you can also use the YouTube C++ lecture 4 custom type and function to watch that. Is that okay?
Okay, sir.
I believe your Zoom will be working. So I think we got to start. So today we are looking at custom type. Consider only the struct and then function, so that later we can add on the classes as well. Right. I'll demonstrate with code blocks. Do you have the code blocks open on your machine?
Yes, I have.
Right. So you need to start one. So this lecture will cover the custom type struct, and then we'll look at functions. We've already gone through some of the basics of C++. We know about how to read, write, and then the basic operators that we have in C++, we know them. So we are looking at how we can define our own structure and then use it in a program. We'll also look at how we define our own function and then use it in a program. So these are the two key aspects we're handling within today's lecture. Right, so we'll start with the custom type struct. So if you have a question, you raise your hand at any point, and then I'll let you ask your question, then we explain to you. So, when you say a structure is an entity, okay? And in programming, especially with C++, when you define a structure, it represents an entity, which is anything that you can record details about. Anything we can record details about. So, example, you are developing a program. Yeah, can you hear me? Great. I think there is, okay. I think there was some echo somewhere. Good. We are continuing from there. Right. So we are allowed to define type, which is a custom type in C++. Some other languages, they have some keywords that is used to describe custom types. C++ has also gotten its keywords. When you say a custom type, is a type other than the primitive types that comes with C++ or any known type which you have been using for the basic operations that you were doing. So we have something like the int, the float, double, bool. They are all custom primitive types in C++. right? When they define objects, or when you define an item of such types, they are that. There is no extra details about them that you need to worry yourself about. It's just a single value representation. But with custom type, you can have multiple values representation. If you define, for instance, extract, you define a set of attributes regarding the entity I mentioned earlier. I said an entity is anything you can record details about. So example, you are working on a program that deals with books, all right? Maybe sale of books. The book can be an entity because you can record the details of the book. Maybe for you to sell the book, you need the title, you need the unit price, okay? And then maybe you can even talk of the quantity of the books in stock. Right. In that sense, a book has become an entity because you record details about. In the same scene, you can also have something like the sale. Why is sale an entity? Because we cannot see sale with our eyes. It's abstract in nature, but it is an entity because you can record details about. Example, who sold the books, who bought the books, which books were bought, and at which date was the book bought, etc. of that nature can also be recorded concerning the sales. Right. So when you say an entity is anything you record details about. Now, in a program, object-oriented programming, an entity can be represented as a class, or maybe as a simple struct. So it's not all the time you need a class. Maybe at times you just want to store the properties and then use it for something. You don't need any operation on such object, okay, to be built inside that object. In that sense, it shouldn't be a class. You should create a struct to represent it. So example, I'm working on a project where I'll be dealing with, say, point, okay? I mean, point in a graph. A point has got two major properties, the X value or coordinate, and then the Y value or coordinate.
Hello, sir.
Yes, sir.
Please, are you sharing a screen?
Yes.
But I can't see
it's
it.
not visible at your end there, okay. Let's check it out. I'm using code blocks for the implementations. We said we're going to make it more practical than anything. So do you see my screen?
Yes, sir.
Good. Great. So this is my code blocks interface. I've maximized. Is it still visible?
Yes, sir. It's okay.
That's great. Yeah. So what we are saying is that we are allowed to define custom types, and we can use a class, an interface, an enumerator, a structure. In most programs, these are the key things that are used to define custom types. Right, but today we are just looking at the struct part. A struct is a bit different from a class in the sense that you may need just the properties of an object, okay, when you want to work with such an object. You don't need any operations or method inside that object. In that sense, use a struct. but where you need both methods and then the properties of an object maintained in that particular object in a program, then that is where the classes and then the interfaces will be necessary. Okay, so extract, as I have said, will define a certain object. It will describe a certain object for you in terms of characteristics only or properties only. So remember that key thing. But a class will have both properties and then methods that work on the properties within that class. So in C++, if you are in the same program, then you define your struct before the int main so that it will be public to all other methods. If you want it to be private to a particular method, then you do it inside the method and C++ will not complain. But for it to be accessible everywhere within the program, we define them globally. And this is where we define them for the int main. Right. The keyword struct is needed. And then the name you want will be mentioned. And then you open your curly brackets. You list all the members within the struct. So this is the syntax for defining a structure in C++. Struct, the name of the struct, and a list of members. When I say list of members, I mean the properties you need to define. Each one should have its data type. So example, I want to create a structure that will represent, say, a book. We know I'm selling books, and a book will have a title. I'm talking about textbooks. It will have a title. It will have the unit price, the quantity I have in stock. Okay, and then maybe where necessary, the ISBN. Okay, so I'm selling books, and these are the things I need to record about the books. Then, if I wish to define a structure for the book, I have to say struct book, and then the members, as I said, maybe the ISBN is necessary. The title of the book is also necessary. We also need the unit price. The unit price can be floating point or decimal. Okay. I'll also need the quantity in stock. And books, we sell them in wholes. We cannot sell half of a book. So it would be maybe, if it's large quantity fair, then int is okay. Otherwise, short would have been better. Okay. Right. So this is a typical structure. And as you can see, the keyword struct is mentioned, followed by the name. Curly bracket will begin. And then we define all the members that we need within the book. Right. So if you create something like this, then the book has become a data type in C++ that can be used to declare our variables. So this is a typical use of the struct. I want to define an object called bottle. A bottle has a color. A bottle has capacity. Okay, capacity as in liters. How will I define a struct to represent a bottle? Can you guide me? Fanny, are you there?
Yes, I'm here.
Good. So I want to define a bottle as a structure. And I'm saying a bottle has a color. Maybe blue bottle, red bottle, white bottle. And then it also has capacity as in liters. Maybe 0.3 liters, 0.5, 1.5 liters. Right. Can you guide me to define such a structure?
So, structure bottle,
The keyword to use is what?
struct,
All right. Go ahead.
bottle.
Mhm.
The strength capacity,
Look at sample capacity, 1.5 liters, 2 liters, 0.3 liters. So what should be the appropriate type for the capacity?
1.5.
What should be the appropriate data type?
Say int.
1.5 is not a
Liters.
whole number.
Okay.
It's not a whole number.
The float will be
Good. So capacity, float, and then the color.
the
What?
color
Red, blue, green. I mean, some words like that. We don't want to use
Green.
any predefined. Okay?
blue.
I mean, it's color. It's when you are using that, you have to supply actual values.
Okay.
Is that okay? During the definition, you tell us the types we need for each field. Okay?
Okay, sir.
Right. So that's good. We are writing a program. We need an object to represent a point. A point has X and Y coordinates, and they can be floating point numbers. Can you define a point?
The struct point. And int.
I say floating point values.
The floating point. Okay, float.
Okay.
Float Y.
Are you okay?
Yes, sir.
So that is how we define a structure in C++. Other languages such as VB, and okay, we'll use the keyword structure instead of struct. And maybe Java will not use any keyword to represent a structure, but you can define a class that will behave like a structure. So every language you go to, you have to know how they define a structure. But the understanding is that a structure is a description of an object in terms of just the characteristics or the properties. We are not interested in the operations of the object, okay?
Okay, sir.
Right, so we take the next action. Now that you defined a class in your program, you can define them in some other places aside this current program. Then you import and make use of them. But we are assuming that we are doing everything within this program. Right, so once you define those structs, they have become data type. All right, so I can create instances of them and then make use of them. So maybe there are 3 books I want to create, right? Book 1, book 2, book 3. So I can say book. Let me use B1, B2, B3. All right. So this is telling me B1 is a book, B2 is a book, B3 is a book. As you were doing with int, so int x, y, right? Means that x and y are integer values. In our case here, we are using B1, B2, B3 as the instances of a book. Is that clear to you?
Yes, sir.
Right. Now, some people, they don't want to trouble themselves coming down here before they define that. So whilst working, okay, so this maybe point 1. Whilst working on the definition, they define a variable of that type already. So we are allowed to also do that. So it's either you finish doing everything, then when you need them, you make use of them, or you can define variables of the type whilst defining. So it's choice. Is that clear?
Okay, sir.
All right. So how do you use the instances of those structures? Unlike a class, we don't need something like the new command before we create the instances. As soon as you define a variable of that type, already they are instances of they are instances of that structure in that program. So book 1 can have its own properties. Book 2 can have its own properties. Book 3 can have its own properties, but they are all book, okay? They are all types of book. So for me to use any of the instances and set the properties within the program, okay, I'll mention the name of the object, dot, which of the properties I am interested in. So I want to set the SBIN for book 1. And the SBIN, I want to make it maybe 6. Okay, something like this. This is the SBIN, ISBN of that book. And I want to have another property of book 1 set, maybe the title. Okay. Introduction to C++ practical approach. Right, so this is another book, right? Maybe the author, when you remember, you need to add additional field. I mean, you should have prepared before defining them, but let's assume the author is necessary, okay? The author has been added as one of the properties. So who wrote this book? Maybe it's me. So I can set the book 1, the author, okay? And the author is Nixon. Okay, I want to set the book 1, its type quantity, right? The quantity is a number, it's a float. Sorry, it's an int, so we don't need to quote the value. Maybe I have 100 copies in stock, and B1, its unit price, okay? Maybe one of them in Ghana cedis, maybe is 45 Ghana cedis, okay? Yeah, I've added F to make it float, okay? I don't want the system to trouble me. Maybe there is another book, book 2, which is Banier's book. So the author is Banier, okay? Banier, is that how you spell your name?
Yes, please.
Okay, so what's the ISBN of your book you wrote? Okay, so maybe yours is 7-5, okay? And then what's the title of your book? Tell about title of your book. Give me the title of your book you wrote. You don't have the title of your book, and I've given it to you. All right, so maybe mine costs more than yours. So yours is 30 cedis. Okay. And then the quantity we have in stock, okay, we have around 50 copies. Bani, are you following?
Yes, sir.
All right, this one, let me add 0.0f. I mean, it's float, not double value. Okay. Float literals, we put F against them. Okay. What's the name of your colleague?
Our Mohammed.
Good. So our Bania what?
Bashkov.
Okay. All right. So we have book 3. You see, I'm making a mistake because I'm setting the property for the third book. So I'm supposed to refer the variable that holds the third book. Is that okay?
Yes, sir.
Okay. So we have the title. And the title of the book is right. So B3K, maybe the quantity in stock is maybe 12. They've bought a lot because everyone to dance to the neighbor. B3 unit price, but it doesn't cost much because it's okay. It's this much. People are buying it a lot. It's not costly, right? So as you can see, the struct defines the properties, the things we need to provide values for. Here they are. Okay, and then we supply values for them when we create instances. We could also read into them instead of we setting them up like this. Okay, but here we want to set their values ourselves. But we write the program that will read the details of the books and then maybe store it in some array or something. All right, but the idea is that we set the properties once we create an instance for. Okay, what haven't we set for our book?
Sir, hello, sir.
Yeah.
ISBN.
Good. So suppose we print to the screen the ISBNs of the books, book 1, 8 ISBN. This is how we print the ISBN of book 1. Let me use tab to separate them. Book 2, ISBN, and tab to separate book 3, ISBN, and line. So suppose my intention is to show the ISBNs of the various books, all right? And then I write this, okay? I want to see the ISBN of book 1, book 2, book 3. That's why I wrote the code. Let's run the program and see. Okay, so guys, since you're not seeing the screen that way, let me show. We're sharing the screen so that you can have access to. I hope you can see my screen.
Yes, sir, I can see.
Right. So I hope you can see my ISBN, yours, but ours own is not there, right?
Yes, please.
The reason is that we didn't set that property for that instance of the book, right? So that's why we are not seeing. So let me quickly give you something, ISBN, and then we provide the ISBN. Okay. So you can see this time, all the ISBNs are shown to the screen because I've given the properties as such. Right, so basically, that is how we define a struct, and then that's how to assign values and then maybe assess the values. So to use all your structures you defined, you have to create instances and then use the dot reference to refer to each member, and you'll be able to maybe show it to the screen or do some computations out of that. What if you want to read the details from the user instead of you setting, okay? Okay, so to read, all we need is to ask the user for the particular property, and then we read into the appropriate property. So example, our book, I'll ask for the title, the ISBN, the author, and so on. And to do that, you communicate with the user. So see out, please enter ISBN of the book. And mind you, they don't know I have defined a structure behind, okay? Users don't know that. I have to read into the appropriate variable in my program, okay? So the ISBN for book 3. So I'll mention book 3, and then I'll say ISBN. So when I do this, it means you should read into the ISBN property. Is that clear to you?
Yes, sir.
Right. So I want you to ask for the title and read it. So you say see out.
See out. Please enter the title of the book. Scene B3 title.
So the dot is very important. Is that okay? If you omit the dot.
So what is the function of the dot?
That is what is used to refer to the member of that object. Is that okay?
Okay, sir.
Okay. So you are saying book 3, your title. So you put the dot there. Is that okay?
Okay, sir.
Okay. You want to read the author? You see, C++ is case sensitive, and you have to mind the spelling you use during the definition and use the same thing. Okay.
Okay.
Okay, so I need a unit price. So I call the unit price property slash. All right, so I hope you've gotten the concept how to read into it, right? So if you are done and you want to show the ISBN as well, it will show. So it's only the reading part we altered. Okay. So it says you should enter the ISBN. Okay. The title. Oh, it's having trouble. Read the title and it skipped the author, it skipped some other things. There is trouble somewhere. You know, the C in takes one word after the other. Okay, it takes word by word. It cannot pick multiple words. So to correct this kind of problem, you need to use a constant character set for string that is more than one word. So like your name, for instance, I'll have trouble reading it because it's more than one word. The title, the same idea. So we need cin.get, to do such kind of reading. So the type 2 usually should be constant characters, meaning an array of characters. Okay. So let me try using the correct thing for the title. So the scene has a get line. Okay. I think it's get line, not just get. I'll try to get if it doesn't have. The get line is the appropriate one to use. Okay. So it's supposed to be get line. Okay. Yeah, but usually you need to specify how many characters you want for the get line. So maybe the title should not be more than 100. And the data type should be a constant char. Right. So you're still complaining about the title. So let me go in and choose appropriate type. Okay. So the title cannot be mere string. Okay. So I'll use character array of size maybe 100 characters. Okay. So that one, it didn't have trouble. Okay. Your name too is made up of multiple words. So we have to apply the same thing. Now that I have changed, I cannot automatically set it like a normal string. All right. So if I wish, I'll make it an array of characters. Let's see. That's the type for us. It's supposed to be multiple characters, but I'm not sure whether it will pick. Wow. It's two ways. I can use the copy one to work out. Okay. You need to cast. I mean, we need to convert. The reason being simple, this is a character array, but I'm giving it a whole string like that. So there's two ways. It's either you are reading with a const char, or maybe we cast this one to a string, to a character. Okay. Is Ralph part of this class?
He is a regular student.
Okay, but he's part of the, C++, right?
Yes, please.
This is very complex. I cannot do this. Do single code for each of them is bad. So if I can convert a string to, let me see. To array. What I want to do, I have to add something else, and I don't want to. You let me comment it out. All the const chars later we'll fix that one. Okay. We just want to learn how to read into string. Oh, which one did I comment? I'm commenting this one. Good. So this time we can read into the title. Okay. So the ISBN is blah, blah, blah. Then the title of the book is Johnson. Okay. Yeah, it's still reflecting the same thing. It's still reflecting the same issue there. Yeah, but that's the essence of the get line. Okay, I'll let it be the last thing to read. Okay. There is a mix of characters and then they're still having the same issue. Even, oh, no, I'm supposed to read author. I'm reading the author, not, okay. Then the unit price. Yeah, the same issue will occur with the author. So we need to also make it a const-char of a certain length, meaning it should be an array of characters. And then we use the get line to read. So where you have multiple words to be read as a string, it's appropriate to make it a const-char. In C++, or not other language, a const-char, then you read into them respectively using the get line, okay? So the unit price and then the stock quantity, okay? And the title did not come here, okay? But it showed the results we wanted to output straight away. I'm not sure. I'm not sure why it's skipping the read. This one you shouldn't skip, but it's skipping. Okay. It's skipping this line. It's all because of the mixed streams, okay? It's mixing the streams, so it gets confused at times. Yeah, but the idea is that where you need multiple characters with space, you should make them an array of characters. And you should know the number of characters maximum. And then for single words, you can use the normal string to be the type, right? So the author, for instance, also need to be char, and I have to know the maximum length of the author's name. Okay, but the ISBN is okay because there is no space in ISBN. So that is only C++ issue. Other languages don't have such issues. So the string and then the char array, okay, they are all strings in some form. But when you make it char array, we can use the functions that can read into char array to do the reading, so that we can avoid the system skipping some of the readings for us. Right, so that is how to read. That is how to define objects of that type. Okay, you can do it on multiple lines too, but because they are the same type, that's why we listed them just like that. Okay, aside having individual variables of that type, you can create an array of that type too. So I can have an array of points, an array of books. So let's assume I need 10 points. Okay, so, and each one shall be called a point I. Okay, then this is a typical array of points. Is that clear to you?
Yes, sir.
All right. So this is an array of points. So it means point 1 will have its value, point 2 will have its value. And you can read the data from the user into the points. So let's assume you want to draw points on the screen and you are asking the user to give you a set of points for you to draw. Then you need to take the input from the user. Okay, so you can look to do that. So I can say for I starting from 0, I less than where should I end? Less than 10, right? So I can ask for x coordinates for point 1. So enter x coordinate for points. Then I'll concatenate the point number. So 0.1, 0.2, 0.3. Okay, so I plus 1. We'll put here. So I will see on the screen, enter the x coordinate for 0.1 when I is 0, and then I'll read into points I. You see, you said the points is an array. So if I say point I, it means the current point. But what do I need concerning the current point? Dot x. So it means you are reading into the x coordinates, right? So I'll do that for the y coordinates. So I'll say enter y coordinate for points. So and so. And is the y value I'm interested in. Okay. So this will read the x point, the y point values for each of the points, because you say I start from 0 up to less than 10, meaning all of them. Okay, so it will be picking them one by one. When it is 0, to put 0 here. When it is 1, it will put 1 here. When the I is 2, put 2 here. So you see, it will be changing. When you are done, you can print out the points. Okay. Let's assume I want to print out the first point, P1. And point 1 will have coordinates in this form. Okay. I want to show XY in this form before I end the line. Okay. So I have to replace the X value, the Y value with concatenations. Okay. So I said the first point, so point 0, I need the Y coordinates. Okay. The same point 0. X coordinates. Right. So this will be able to show me the first points on the screen after reading all the 10 points. Let me reduce the size to maybe just 3 so that we won't suffer entering the X and Y coordinates. Okay. Please, are you following me?
Yes, please.
Right. So we want to read all the points, but we are just cutting it at 3. And then after reading all the points, we show the first points, its coordinates to the screen. So P1 will be that first point, and we'll see its coordinate after reading. So on the screen, we see enter X coordinate for point 1. So let's assume it's 5. Point 2, the same point 1, but the Y coordinates maybe is 2. The other one is going to be 3 and so 6. The other one is going to be maybe 3, then maybe 1. Okay, so 3 points have been captured so far. And I want to see the first point. The first point, the coordinate will be 5,2. So you can see it's saying that P1, 5,2. Is that okay?
Yes, sir.
Right. So you don't care whether you define an array out of your struct or maybe it is just a normal variable. Okay. And another good thing is that whilst you define others, other types, okay, they also become a type that can be used in another. Okay, so maybe the book, you want it to be referred, a point will have a book. Okay, so I want a point to contain a book. So book, and then I say something like that. Okay, so it is telling me that a point has got X and Y coordinates and it contains a book. Do you get a trick here?
Yes, sir.
So it means we can set a book for the point. And to set a book, you should have read all the details of the book before you assign that book. Okay, so let's assume the point one. I mean, the first point. I want to set its book. You can read the details of the book as well, and then assign to it from the user. Okay, so the book is equal to B1. So it means all the details of the book, let me make them strings. We assume they are just one word so that it won't trouble me with the character reading. I don't want to bother myself with the character reading. So let me make it string. Raf, you are welcome. Is Raf in? Right, so let me check here. Good, so let me uncomment this one. Set the title, set everything, and give it to that point. So you see, I set everything about the book and about that point, and I'm setting the book for that point, the first point, its book. So if I want to show the book associated with the point, okay, so I will say this is the point, and its book title is, right, so I will show the book title, or let me simply say the title of the book here. All right, so I want to show the title of that point. So point I, its book, all right, its title, I want to see. Okay. Oh, I need to quote. Great. You say I was, oh, sorry, I said 0.0, sorry. 0.0, not I. You know, we are talking about 0.0, the book we set to it. So you see, look at the way I'm referring to the title from the points type, from the points book title. Okay, I'm saying that 0.0, its book. So I say dot book, its title, the book's title. That's the meaning. Okay, so let's see. So I read the points. Okay, so 5 against 2, have 6 against 3, and 3 against 1. Okay. So you see, it says that point 1 is 5.2, and the title is Introduction to C++ Practical Approach. Right. So this is telling you, once you define a structure, it becomes a data type, and we can make references to it from any part, whether in another structure, in a certain class, okay, I mean, in the program straight away. Right, so book, which was predefined here, okay, has become a data type that can also be referenced in the point structure. So one struct can be used as a type for a member of another struct. And one good thing is that, let's assume you want to build a chain of bottles. Okay, then we can refer a bottle to itself. I mean, a type can also be referred by itself. Okay, so it means a bottle can contain a bottle if you wish to do that. So maybe bot link, okay? So I'm saying that I have a link that will connect me to another bottle. Have you seen? So a bottle is what I'm defining, but I'm using that same bottle as a type in itself. Yeah, C++ will allow you to do that. In object-oriented, we are able to reference other objects through us, okay? So it's a good thing that we can make reference to ourselves so that where we have a chain of items, we can easily handle that. Like the blockchain, you have a block, another block, another block. If you want to link them up, then you use a link to connect them up. And it means a block contains a link to another block. So this is a bottle contains a link, because I'm using a pointer, a link to another bottle. So it's the same thing I'm defining, but I've referred it in its own self. We're allowed to do that. We're allowed to do that. So basically, this is how we define a structure, and how to use it is as simple as that. You define any variable of that object. If you wish to have an array of that, it will work. If you even want to have a matrix of arrays, okay, maybe 5 by 10, 5 by 10 points you can have. So this means it's going to contain 50 points. So this is two-dimensional array of the points. We don't care whether it's 5 by whatever. How we use normal variables normal types when they are in array is the same idea. Nothing changes. The idea is that once you create a structure, it becomes a data type that can be used in a program. It's a custom type, so that's the nature. Do you have a question to ask? Banya, you started with me.
No, sir. I'm just following you.
But so it's clear, right?
Yes, sir.
Good. So let me give you a question right now, then you tackle it yourself. Define a structure to represent Do you hear me?
Yes, sir.
Define a structure to represent a fan. A fan. Full stop. A fan has number of blades, a brand, color, whether red, blue, white, green. And the year of make, whether it was made in 2010, 2011. So define a fan as a structure. Let me see. Are you done? Bani, are you done?
I'm on it.
Okay. I give you access, okay? I make you co-host, so you can share your screen, what you did. You're a co-host.
Okay, so but I'm writing it.
Okay, so tell me what you've written so far. Because of time.
Okay, so see out, enter the number of blades.
No. I say define a structure. I didn't ask you to read any data. Define a structure that represents a fan.
The structure. Okay. The structure bottle. I structure fan. Floats. Number of blades.
Why did you choose float?
So because it's not a single digit.
The number of blades. The number of blades can be 3 blades, 4 blades.
Okay. Then int. Number of blades.
It should even be short.
Short rather.
Yeah, but it's okay if you say int. It's also an integer. Go ahead.
Okay, so string the color. And then string the brand. And int the year of make.
Yeah, so it was as simple as that. Okay, I want you to create an instance of a fan, and then you provide a typical set of values for it. Create an instance of a fan and provide the property values. Go.
So int main.
No, we are int main already. Look
Okay.
at the screen, or you can.
Okay. Fan.
Create an instance of fan. Call it F, and then set some values for it.
Okay. Fan. B1.
No, I said
okay,
call it F.
F. Okay.
Set all the values, typical values for it.
F1.
You call it F, you didn't call it F1. So.
F.
So maybe it is a 3-blade fan. And the color is white.
So why don't we use the C out?
No, I said you should set values for it. I have not asked you to show something to the screen. Okay. You only use C out when you are showing something to the screen.
Okay, the C out is used for printing.
Yes.
Okay.
Okay. So what would the brand be? What's the brand of your fan?
Hisense.
And then the make year.
Yeah. 2021.
Okay. So now I want you to show me the brand and the number of blades of your fan, the one you just created.
Okay. See out. Please enter the.
I say, show me. No, show me. You've already created your fan.
Yes.
So show me the brand of your fan and then the number of blades. Just show it to the screen.
See out. Enter the number of blades.
No, sir. When it says here, enter number, it means you are going to ask me for something. And you are not supposed to ask anyone. I say, show, you just created the instance of a fan. You've set the properties already. I want to see the brand and then the number of blades of your fan that you just created.
See out. Number of blades.
Number of blades doesn't exist by itself. It's found in a fan. F dot number of blades. You get it?
Yes, sir.
Is found in the fan that you created. So F is the fan that you created. Right. So I want to see the brand as well.
F dot here. The brand.
Okay.
F dot brand.
So that's the only thing I needed to. Okay. I want you to create another instance of fan. Call it F2. And then read the details of the fan from the user. Let's go. Create another instance of fan called F2, and then read the details of the fan from the user.
Okay, so fan F2.
Go.
Int number of blades.
No, sir. You've created your fan. The fan contains the number of blades, etc. for you. You are just going to take the details from the user. So ask the user for it, and then you read into the appropriate field. Let's go. So ask the user for the number of blades. Ask.
Okay.
Then you read into which of them. So you are reading into
seeing. Number of blades.
No, sir. Number of blades cannot exist on its own.
Okay. F dot.
No, sir. I say you are reading
F2.
into the one you just created.
F2 dot number of blades. See out.
That's okay.
F dot. Please enter number of color. Enter the color. Of one.
Go.
Seeing. F2 color. F2 dot color. See out. Please enter the brand of fan. C in F2 brand. C out. Please enter year of make of the fan. C in F2 year of make.
Are we done?
No, C out.
What else are you reading about the fan?
Say the year of make and the brand.
But you just read them.
Yes,
and so what do you want?
Okay, I just wanted us to end it.
You want to show the year of number of blades. What do you want to show? Do you want to show something about your fan? What do you want to show?
The make year and the brand.
Okay, so F2 dots.
Make year. F2 dot brand and L.
So that's cool. So you've been able to define your own structure called fan. And these are the properties of the fan or the members. And you have been able to set the values yourself in the code. And you're also able to take the values or the properties from the user and then assign them to the respective properties of the fan. And you're able to access the various field by showing to the screen. So it's as simple as that. Is that okay?
Yes, sir.
So anytime you are asked to define a structure, all you must know is what are the properties of that structure and what is the name of the structure. And then if you want to use that structure, all you need to do is to create an instance of it and you use the object to set out the properties as you wish. So I think our time is up, isn't it?
Yes, please.
So I think we'll end here and then continue with it next time we meet on the functions. So if you have a question, you can ask before we end it here. You have any question?
No, sir, but I will try my hands on it and I'll show you.
No,
I'm going to
give you your exercise. So
assignment.
Yes, I'll drop it in your what do you call it? Telegram. Okay.
Okay, sir.
All right. So have a nice day.
Bye.
Bye.